For generations, astronomers have wondered whether other worlds might exist around the stars closest to our own. Among all nearby systems, Alpha Centauri has always been one of the most fascinating. At a distance of only about 4.37 light-years, it is our nearest stellar neighbor. Its resemblance to the Sun has made it an especially attractive target in the search for planets. Yet despite decades of observations, finding a convincing planet around Alpha Centauri A remained extraordinarily difficult. The problem was the stars themselves. Alpha Centauri is a complicated system containing multiple stars whose intense brightness can overwhelm instruments searching for faint companions. Even a planet reflecting or emitting a tiny amount of light can disappear completely in the glare. Then astronomers attempted something particularly ambitious with the James Webb Space Telescope. Webb was designed primarily to investigate faint and distant targets, including ancient galaxies and remote planetary systems. Observing an extremely bright nearby star presented a completely different challenge. The intense light from Alpha Centauri A could create unwanted signals and overwhelm sensitive detectors. Its stellar companion added another layer of difficulty. Even precise pointing became complicated because the system moves noticeably across the sky. Nevertheless, observations were carried out, and researchers subjected the resulting data to extensive processing. Something unusual appeared. A faint source seemed to be located roughly 2 astronomical units from Alpha Centauri A. Instead of immediately accepting the result, researchers treated it as a problem that needed to be attacked from every possible direction. Could it be a background star? Could it be a distant galaxy? Could it be an object within our own solar system? Could the telescope itself have produced the apparent signal? Each possibility had to be investigated. Background sources could be compared against astronomical catalogs. Objects moving through our solar system could be checked by examining their motion. Instrumental artifacts could be investigated through specialized testing and simulated signal recovery. The mysterious source continued to stand out. The reported signal appeared statistically significant, making a simple random fluctuation an unlikely explanation. For a moment, the possibility of a planet around one of the closest Sun-like stars became much more serious. But detecting something once is only the beginning. A genuine planet should move. Its position should change according to an orbit governed by gravity. If astronomers observed the same system again, the object should appear somewhere else along that predictable path. So additional observations became crucial. Follow-up observations were carried out months later. And then the mystery became even deeper. The region where the faint source had previously appeared no longer contained an obvious detection. Instead of a clear planetary signal, astronomers found what appeared to be ordinary background noise. At first glance, this seemed devastating. If the object had really been a planet, why wasn't it there? Planets do not simply disappear. But there was another possibility. Perhaps the planet had moved into a location where the telescope could no longer detect it effectively. This is particularly important when observations rely on coronagraphic techniques. These systems suppress the overwhelming light of a star so that nearby faint objects can be studied. But the same process creates areas where detection becomes extremely difficult. If the suspected planet followed an unusual orbit, it could have moved into one of these observational blind spots. That would mean the missing signal was not necessarily evidence against the planet. It could actually be consistent with the planet's orbit. Computer simulations suggested that certain eccentric or inclined trajectories could allow an object detected during one observation to become extremely difficult to see during later observations. Suddenly, the disappearance had another interpretation. The object may not have vanished. It may simply have moved somewhere Webb could not see. And that possibility created an even bigger question. If this candidate really belongs to Alpha Centauri A, its orbit could be remarkably unusual. The gravitational influence of the companion star makes the environment far more complicated than the space around an isolated star. Instead of traveling along a simple circular path, the planet could follow a stretched or tilted trajectory. Such an orbit might explain both its apparent survival and its temporary disappearance. But that would lead astronomers toward an even deeper mystery. How could such a planet have formed there in the first place? The mystery surrounding the possible planet near Alpha Centauri A becomes even more complicated when scientists consider how such a world could have formed. Planet formation normally begins inside a disk of gas and dust surrounding a young star. Over time, tiny particles collide and gradually build larger bodies. Eventually, those bodies can become planets. But a binary system introduces another major complication. Alpha Centauri A does not exist alone. Its stellar companion constantly influences the surrounding gravitational environment. During the system's early history, that gravitational interaction could have disturbed the material from which planets were trying to form. Instead of allowing dust and rocky material to gather in a calm environment, the companion star could have increased the speed and energy of collisions. That makes the construction of a planet much more difficult. So if the suspected object near Alpha Centauri A is genuine, astronomers face two separate puzzles. First, how can the planet remain stable? Second, how did it form at all? One possible explanation is that the planet formed closer to its star and later migrated outward. Another possibility is that the planetary system developed through processes that current models do not completely describe. Neither explanation is simple. Planetary migration inside a binary system can be complicated, and the precise conditions required for long-term stability may be unusual. This is why the possible detection is so interesting. It is not merely about discovering another planet. It could provide an opportunity to test how well existing theories explain planetary systems around multiple stars. For decades, astronomers have studied thousands of exoplanets. Those discoveries have shown that planetary systems can take many different forms. But Alpha Centauri offers a particularly valuable laboratory because it is so close to Earth. At only a few light-years away, the system is one of the easiest stellar neighborhoods for future instruments to study in detail. If a planet really exists around Alpha Centauri A, future observations could eventually reveal whether the candidate was real, determine its orbit, and potentially learn more about its atmosphere and physical properties. But there is an important distinction between an intriguing detection and a confirmed planet. A single observation, even a highly significant one, does not automatically settle the question. Independent observations are necessary to establish that the source truly moves with the star and follows a planetary orbit. That uncertainty is what makes the story so fascinating. The James Webb Space Telescope may have encountered something that behaves exactly like the kind of difficult object astronomers would expect from an unusual planetary system. Or the signal could eventually receive another explanation. Either way, the observation demonstrates how challenging exoplanet astronomy can be. Sometimes the greatest obstacle is not distance. It is brightness. A planet can be extremely close in astronomical terms and still remain hidden because its parent star is overwhelmingly bright. Webb's infrared capabilities and advanced coronagraphic techniques give researchers new ways to search through that glare. But even these powerful instruments have limits. The possible Alpha Centauri candidate therefore represents something bigger than a mysterious dot in an image. It represents a test. A test of detection techniques. A test of orbital models. A test of planetary formation theories. And perhaps, eventually, a test of whether our nearest sun-like neighbor hosts a world we have never been able to see clearly before. For decades, Alpha Centauri seemed like a nearby system that should have been easy to understand. Instead, it may be proving the opposite. The closer we look, the more complicated the system becomes. And if future observations confirm that the mysterious object is truly a planet, one of humanity's nearest stellar neighbors could become one of the most important planetary systems ever studied. The universe does not always hide its greatest discoveries billions of light years away. Sometimes, the mystery may be waiting almost next door.